Bismillahirrahmanirrahim. Today we're going to continue with the reactions of phenylamine. So yesterday in the previous lesson we looked at the reactions to form or to produce your alkylamines as well as your phenylamines. Okay. So your learning objective requires you to know the reaction of phenylamine with aqueous bromine as well as nitrous acid to give the diazonium salt. So the second reaction is something that you have already done in topic 18. Okay, so the first reaction is the reaction of phenylamine with aqueous bromine. So this is a reaction that you can compare with when benzene reacts with bromine. Okay, for benzene, you need not only you need your bromine to be in liquid form that is dry, you also need a catalyst, aluminium bromide, and it has to be anhydrous. Okay, so that means no aqueous solution. And also with benzene, you can only have mono substitution or di substitution in as per reaction. Okay, for phenylamine, you will see that one, you do not need a catalyst to react phenylamine with bromine. You can use aqueous bromine or bromine water. It means the same thing. And for phenylamine, there is a tri-substitution happening. Substitution. Okay, so NH2 activates the 2,4,6 position. So all the 2,4,6 position all the hydrogens in the 2,4,6 positions have been replaced. Okay, this shows that phenylamine reacts with bromine more reactively compared to benzene with bromine. Okay, so the observation you would see is the first one is the appearance of your product, which is 2,4,6 tribromophenylamine. The product is similar to that of when phenol reacts with bromine, where you get a 2,4,6 tribromophenol. It appears as white precipitate. Okay, and another thing that you can observe is your bromine water going from reddish brown into colorless HBr. Okay, so these are the two observations that you would expect. And steamy fumes of HBr in the form of a fume, steamy fume. Okay, next, why is phenylamine more reactive than benzene? First, we need to look at the structure of phenylamine. Okay, so you have an NH2. Okay, and as you know, the benzene ring, there is a delocalized system. Okay, where all the p orbitals on each carbon, they overlap, they align to form a delocalized ring. However, additionally, on the nitrogen, okay, where the lone pair sits, it sits on the p orbital as well. Okay, so in benzene, the delocalization of the pi bonding system is only limited to the one inside the ring. Okay, with phenylamine, the delocalization is extended throughout and including the lone pair of the nitrogen. So the delocalization looks something like this. Okay, so the lone pair of the nitrogen will move inside the ring as well. Okay, so this is why we say that phenylamine is the least basic, because the lone pair is not available for it to be used for bonding with H+. Instead, the lone pair will be moving inside the ring. So explanation for that is phenylamine is more reactive than benzene to its electrophilic substitution because the nitrogen in phenylamine has a lone pair of electrons that is localized into the pi bonding system of benzene ring and makes it more readily attacked by the electrophile. So because you now have a bigger electron density inside the ring, therefore it will attract the electrophiles even better. Okay, NH2 is what we say an electron donating group, because as you saw just now, the lone pair of nitrogen goes into the ring, or another way, delocalized into the ring. So in a way, nitrogen is donating the lone pair to the into the ring, and therefore it activates the 2, 4 and 6 position. Okay, so this is the same as other electron donating group like your alkyl or your phenol. Okay, so they all of these electron donating activates the 2, 4, 6 position. So that explains why phenylamine is more reactive than benzene. Okay, so next we're going to look at the reaction of phenylamine with nitrous acid to give diazonium salt and phenol. Right, so in your notes you have two reactions that look similar. Basically, the phenylamine reacting with nitrous acid. Top reaction is in under warm condition, or anything that is above 10 degrees Celsius. Okay, and then the below reaction is when the reaction is carried out in a cold temperature below 10 degrees Celsius. Now, I believe that there is a typo in your notes. In your notes, it says below 5 degrees Celsius. So change it to below 10 degrees Celsius. Okay. So with different conditions you will get different products, obviously. Now, let's have a look at the first reaction first. You have a phenylamine reacting with nitrous acid. Now, you know nitrous acid is not a stable compound. You cannot just have this that comes from a supplier in a bottle. You have to make it in situ. That means you have to make it inside the reaction mixture. If your condition is not is warm or higher than 10 degrees Celsius, you will form a phenol. So this is actually a method or a way of producing phenol. Okay, so phenol cannot just be produced from the reaction of benzene plus OH minus, because that would be electron-rich benzene approaching a nucleophilic hydroxide ion. They will repel each other. So you need to convert your benzene into a phenylamine, and then only after phenylamine you will get your phenol by reacting it with nitrous acid under warm condition. Other products would be water and nitrogen. The next reaction is if you use this phenylamine, which is the same starting material, with nitrous acid and HCl, but this time it's under 10 degrees Celsius. Okay, when you put it at a temperature that is quite low, then you are able to produce a compound that is usually decomposed at high temperature. Okay, so when you use cold condition for this reaction, you will get a benzene diazonium ion. Okay, I hope you still remember this benzene diazonium ion, where you have an N triple bond N attached to your benzene ring. Okay, and then the Cl minus is just a counter ion. So this is called the benzene diazonium chloride, and then you form water. Now, benzene diazonium chloride is something that you have already met from topic 18. So please revisit that topic if this is very, very unfamiliar with you. You really don't remember anything. Okay, benzene diazonium, let me tell you, is unstable in warm condition. Okay, the moment you get a warm condition, this anion will break down to release nitrogen gas, as well as to form phenol. Okay, unstable in warm condition. Warm condition is anything that is bigger than 10 degrees Celsius. So if you want to produce the benzene diazonium ion, you need a cold condition. So the diazonium salt is unstable and decomposes readily to nitrogen at higher temperature. So higher temperature, anything bigger than 10. The nitrous acid, as I said, is also unstable, so it has to be made in the test tube by using sodium nitrite and dilute HCl. Okay, so this reaction is the equation that you need to form nitrous acid, which is not something that we can find available from supplier or in a bottle. You have to make it on the spot. Okay, so just to make sure to re-emphasize on the structure of a benzene diazonium chloride, the diazo stands for the 2 nitrogen group. Okay, the benzene is obviously the benzene. The chloride, as I said, is the counter anion. Okay, one thing that I want to emphasize as well is this nitrogen, the one that is directly attached to the benzene ring, has a charge of positive, because that nitrogen is the one that has 4 bonds around it. Meanwhile, this nitrogen in blue, oops, okay, so the other one is the nitrogen in blue. So the nitrogen in blue only has 3 bonds, so it doesn't have any charge. Okay, so benzenediazonium is an ion. The salt that it forms is a benzenediazonium chloride, usually with chloride, but if you have any other anion, it should be okay too. Okay, moving on. Moving on, we want to look at the substitution reactions of diazonium ions. So moving away from the phenylamine, we now look at the diazonium ions. A diazonium ions, the diazo means you have 2 nitrogen. Okay, so it's a 2 nitrogen that is singly bonded to the benzene ring, but triply bonded to each other. Okay, when this benzene diazonium react with water and under warm condition is anything above 10 degrees Celsius, that's when you see the decomposition of the benzene diazonium ion. Okay, so what happens? Decomposition happens, you will form a phenol. This is great. The reaction is great if you're looking for to produce a phenol. Okay, so what happens? You then warm the benzene diazonium chloride solution. The diazonium reacts with the water in the gas solution, and the phenol is formed and nitrogen gas is evolved. Okay, so basically that's just showing you how benzene diazonium decomposes. Okay. This is the same reaction when phenylamine reacts with nitrous acid in the warm condition above. The diazonium ion is formed first and then immediately reacts with the water in the solution to give phenol. Okay, so for the decomposition of phenol, really the requirement is just above 10 degrees Celsius and what is it? And the presence of water. Okay, so if you go back to this slide, okay, where you have NH2 with HNO2, actually the first step that happens there is the production of the benzene diazonium ion. Okay, but you don't see it in the mixture because of the warm temperature. This immediately breaks down or decomposes. Okay, so when it breaks down or decompose, you release the N2 as nitrogen, and then the hydrogen goes to the is directly attached to the OH is directly attached to the phenyl ring. Okay, so if you want to form phenol, it's easy. You just have to warm the benzene diazonium chloride solution. The diazonium ion reacts with water in the solution and phenol is formed and nitrogen gas is evolved. Okay. Describe the coupling of benzene diazonium chloride and phenol and the use of similar reactions in the formation of distuff. So what's the importance of the benzene diazonium ion? We use it to make dye, or we say we use it as a coupling reaction. Okay, so benzene diazonium ion can couple with phenol, phenylamine, and some other aryl amines that you will look at shortly. Okay, so how does this coupling reaction happens? Now, one thing that you need to know is the benzene diazonium ion acts as an electrophile. And phenol, the benzene ring on phenol, is electron rich, therefore it attacks the electrophile. Okay, so phenol, as I said, it activates position 2, 4, and 6. Their first preference is the 4th position. Only when the 4th position is occupied, then we'll go to 2nd or 6th position. So what happens is that there will be something happening here. The nitrogen, triple bond nitrogen, will be broken. One of them, only one out of the three triple bond is broken, and then it forms a bridge or a linkage to the phenol. Okay, so you get this diazo bridge. Okay, the nitrogen is a bridge. Now please make sure that when you start with a benzene diazonium ion and you end with a bridging product, your nitrogen now has only double bond. Originally, in the starting material, the N bond consists of a triple bond. Okay, so just be careful with that. And then you have H plus. I'll explain to you why you have H plus. Now for this reaction, you need benzene diazonium chloride, you need phenol, that's your reagent, but your phenol must be in alkaline solution, and the condition must of course be cold in ice. If you don't have a cold condition, then you would not have this benzene diazonium ion in the first place, because they will decompose quickly. Okay, so the name of the product is a 4-hydroxyphenylazobenzene. So this is the significant or the active ingredient in orange colored dye. This is just showing you the stepwise of the reaction of benzene diazonium with phenol. The reason why we use alkaline phenol, an example of alkaline phenol is really just adding the sodium hydroxide to the phenol. So what happens? Sodium hydroxide as a base will pick up the hydrogen on the phenol to form a phenoxide. So that's a phenoxide. Okay, that's when after the phenol loses its hydrogen ions. I don't know if you remember, but phenol is slightly acidic, so it can lose its H plus. Okay, so then the next step, the phenoxide. Okay, phenoxide will now be electron rich because your you have a negatively charged. Okay, so the phenoxide will attract, sorry, that's the wrong arrow. The phenoxide will attract the benzene diazonium ion, making sure to maintain that everything is under the cold condition. Okay, so what happens? One of this bond breaks, but one of a new bond between the nitrogen and the fourth position of the phenoxide forms. Okay, so this is your product, where you initially have your benzene diazonium ion, and then you have your phenol. So this is an example of a coupling reaction. This reaction also works with not only just phenol, but phenylamine works well with for this reaction as well. Okay, so you have a benzene diazonium ion reacting with phenylamine, making sure that it is cold condition, otherwise you will have your benzene diazonium ion decomposing even way before the reaction starts. Okay, and H2 activates 2,4,6, but the first choice is the fourth position. Okay, so again, one of the triple bond breaks, and then one of the newly bond form is between the fourth position, the fourth carbon of your phenylamine, and also the nitrogen in the diazonium ion. Okay, then you will form H plus. So these strongly colored azo compounds are frequently used as dye, known as diazos. Azo dyes. The one made from phenylamine or aniline is known as alanine yellow. Okay. Another alternative compound is a diethyl phenylamine. Okay, so you have a phenyl group on your nitrogen, and then you have a dimethyl. Okay, so you have two methyl groups attached to the nitrogen. Again, no problem. It is still an amine, and amine activates the 2,4,6 position. The sixth position is the first choice. Therefore, one of the triple bond in nitrogen breaks to form a new bond with the carbon number 4. Okay, so coupling reaction is always happening at carbon number 4 unless carbon number 4 is not available. That means someone else is already sitting there. You cannot just kick it out. Okay, your other product will be H plus. This comes from the dissociation of phenol, when phenol reacts with any bases, okay, sodium hydroxide or potassium hydroxide. Right, so this compound below is a main active or main ingredients in your yellow dye. Okay, so that is all for today. Nothing much explanation. They're all just recalling information, memorizing, the stuff that you like to do when you don't understand things. Right. If you have any questions, please ask me. Otherwise, tomorrow we'll continue with amides. Okay. Assalamu alaikum wa rahmatullahi wa barakatuh. Thank you, everyone.